Stories of giant human fossils are not just limited to conspiracy theorists. In fact, National Geographic once made a documentary about what they called Goliath.
They are the bones of an ancient giant. Paleoanthropologist Lee Berger has uncovered fossils from the largest human species. Call him Goliath. Were our ancestors once giants?
One of the leading archaeologists in the world has repeatedly claimed that there was a species of human, sometimes called the African Neanderthal, walking the earth that was over 7 feet tall. In this video we are going to examine what the evidence shows. One way scientists know they've had an impact is if they've gotten their peers talking. A better way is getting them arguing. A few years ago, Professor Lee Berger, a paleoanthropologist at the University of Witwatersrand in South Africa, rocked the fossil world with the news that he had found a new type of pre-human that lived in South Africa, aka the cradle of humanity. The species, Homo naledi, may not have qualified as the missing link, but it is certainly a strange new species. In fact, Lee Berger was even named a pioneer in the 2006 Time magazine list of the 100 most influential people for the find, and is a National Geographic Explorer in residence. But what is the story with the Goliath specimen discussed by Berger, and reconstructed by him and Steve Churchill, in the 2004 National Geographic program, Searching for the Ultimate Survivor? The femoral fragment found by Berger was apparently from around 300,000 years old. In the program he states that males would have been 7 feet tall, while the females stood 6 feet tall.
This is the tibia of Goliath, if you will. It's a fantastic specimen, 280,000 years old from here at Hutchie's Pent. It represents one of these giants. It would have belonged to an individual that was maybe 6 foot tall. What's amazing is that we think it's from a child or a female, and that puts it right off the scale in height. It was a real giant.
The Kabwe skull is the best-known specimen from the site, but there are also another maxilla and postcrania representing 3 or more individuals. One of 2 bones and 1 femur are quite large, although they probably do not belong to the same individual as the skull. I would assume that the full-body reconstruction on the program used these to estimate and model a very large body size. Ultimate Survivor discusses the Goliaths living in Europe and Africa, which means that they are talking about Homo heidelbergensis. There is a clear division of opinion about this species in the field. Some researchers, myself included, think it is a superfluous name that doesn't describe a real ancient reproductive community, and so we tend not to use it at all. But among those who believe that Homo heidelbergensis is valid, there are essentially 2 viewpoints. Some would limit its application to European fossils only, which is where the type specimen, the Mauer mandible, was found. Others would apply Homo heidelbergensis much more broadly to essentially all Middle Pleistocene European and African fossils, and some specimens from China as well. In this usage, Homo heidelbergensis is basically inclusive of all specimens that have been called archaic Homo sapiens, on the basis of enlarged brain size compared to earlier humans combined with the lack of most of the distinctive features of Neanderthals. According to an article on the Bradshaw Foundation website, Homo heidelbergensis is an extinct species of the genus Homo, which may be the direct ancestor of both Homo neanderthalensis in Europe and Homo sapiens. The fossils have been dated to between 600,000 and 400,000 years ago. The tools used were very similar to those of the Acheulean tools used by Homo erectus. It has been argued that Homo heidelbergensis and the older Homo antecessor are likely to be descended from Homo ergaster from Africa, based on the close morphology. However, because Homo heidelbergensis had a larger average brain capacity than modern humans and used advanced tools, it has achieved its own species classification. Homo heidelbergensis was taller, averaging 7 feet, and more robust than modern humans, according to Lee Berger. Regarding social behavior, Homo heidelbergensis may have been the first species to bury their dead, based on 28 skeletons found at Atapuerca, Spain. Evidence suggests the development and use of a proto-language. The discovery of red ochre at Terra Amata in Italy indicates personal adornment. Dental analysis suggests they may have been right-hand. Homo heidelbergensis was a sophisticated hunter, suggested by wooden projectile spears found at Schoningen, Germany, attributed to this species. In terms of the evolutionary tree, with the spread of Homo heidelbergensis out of Africa and into Europe, the climate at this time would have caused a divergence. Homo neanderthalensis diverged from Homo heidelbergensis probably some 300,000 years ago in Europe. Homo sapiens probably diverged between 200,000 and 100,000 years ago in Africa, or maybe not. Since the emergence of our genus in tropical Africa, hominids have spread to virtually every ecosystem on Earth. Thus, human populations have been exposed to a wide variety of different ecological stressors. Adaptation to these widely differing, selective pressures explains, in part, why Homo sapiens is such a diverse species today.
He is the tallest and most massive human species ever discovered.
So the big question is, was there really a Middle Pleistocene species of giant humans that averaged 7 feet tall? According to a blog post by anthropologist John Hawkes, there were, without a doubt, some people with large body masses. One is the large Cabeway specimen, and another is the person represented by the extraordinarily broad Cima de los Huesos pelvis, who is likely the largest individual in the Middle Pleistocene record. These large specimens were more massive than any early Pleistocene humans, whose average weight was only between 60 and 70 kilograms, or 130 to 155 pounds, and had masses as high as 80 to 90 kilograms, or 175 to 200 pounds. But the overall picture of body size is only partially represented by these large specimens. The numerous skeletal remains from just the one site in Cabeway show a variety of body sizes. There is unmistakable evidence of a mixture of smaller and larger specimens not only in Africa but also elsewhere. Other researchers have demonstrated that this range of variation is not wider than in populations of living humans. A portion of the variation is likely due to sex, and a portion is related to climate. Higher latitude populations are more massive, the largest specimens are undoubtedly males, meaning that there must have been a range of smaller female individuals also. However, they were significant and did not significantly change after the start of the Middle Pleistocene, regardless of the sources of variation. There has been a lot of discussion about the adaptation of some Middle Pleistocene fossil individuals and late Pleistocene Neanderthals, due to their large bodies. Much of this revolves around the idea that early humans were much more physically fit and strong than modern humans. The thicker shafts of many early humans' long bones serve as proof for this claim. In comparison to early Holocene skeletal remains as well as recent people, these shafts typically have quite thick cortical bone and reduced medullary cavities. Early farmers undoubtedly put in a lot of work and did not live in luxury, so they stand out as strong people. Perhaps elite athletes, at least those who competed before the widespread use of anabolic steroids, provide a more accurate representation of the physique and mass of prehistoric Homo sapiens. Throwers, weightlifters, and wrestlers were the Olympic athletes most resembling Neanderthals in build. Despite having narrower hips than most Neanderthals, some of these men weighed as much as 200 pounds. Even bigger and perhaps more accurate body mass estimates could be obtained by using a larger, more physically fit living human reference sample. The standard model of human growth and development does not include the specialized muscle building regimen required for performance athletes. Since hunter-gatherers' access to food is neither consistent nor uninterrupted, it is almost certain that a Neanderthal with the lean body mass of a performance athlete would be at a significant disadvantage in terms of energy expenditure in the absence of a significant fat store. Even though they are strong and lean, today's hunters and gatherers are not particularly muscle-bound. They are not cut, and when they are healthy, they have observable fat stores. The majority of their estimated high mass must therefore be modeled as fat rather than pure muscle, even though I would not suggest that archaic humans were in any way bulky. Compared to the large body mass of archaic Homo during the 2 million years before, the relatively quick decline in modern human body mass over the past 90,000 years is striking. What selective pressures could have caused modern humans to have both a smaller body mass and a larger relative brain size? Although the less robustly built skeleton implies different behaviors, suggesting that modern humans adopted increasingly less active lifestyles. These changes do not appear to be closely linked to technological innovation. We should now consider the possibility that the pattern in modern humans was driven by selection for smaller bodies, possibly favored by a social structure that depended on more cooperative foraging and improved communication skills, rather than focusing solely on models that favor selection for ever larger brains. We can also consider the possibility that declining body size among late Pleistocene humans was a secular trend, and that dietary restrictions became more severe as the population grew. It is almost certainly true that the introduction of agricultural subsistence during the Holocene coincided with a secular trend toward lower mass. Smaller adult body sizes were a result of the early agricultural diet's lower protein and other nutritional content, as well as the higher prevalence of epidemic diseases during childhood.
Berger's work is a revelation. He's analyzing the bones of Goliath to create a disturbing model. The replica will reveal that our ancestors were larger than anyone may have imagined. When we stare Goliath in the eye, will we find an answer to why he is gone and we are here today?
Additionally, research from the past 40 years has shown that as nutrition in developing countries has improved, the disparities in body size among human populations have started to decline. The tall present-day stature of Northern Europeans, which is largely a recent, post-industrial development, appears to partially cancel any prediction of Allen's rule, which means that mass is approaching the same situation as stature. Therefore, Middle Pleistocene humans' body size was influenced by their diet and body composition in addition to their activity level, and adaptation to locomotion. When compared to modern humans, they cannot be referred to as giants or Goliaths. Particularly, modern residents of industrialized societies have mean body sizes that are strikingly similar to those of Middle Pleistocene humans. In today's Western nations, body size is a result of genes operating in a setting with nearly optimal nutrition and low disease and parasite loads. Evidence points to an extremely high animal protein diet in archaic humans, and the small population sizes and low densities are likely to have preserved a low rate of acute communicable diseases and parasites. Archaic humans were able to live and forage in the most productive habitats with the most abundant food sources, unlike modern hunter-gatherers who now occupy areas that were previously unoccupied by agriculturalists. In conclusion, compared to later Upper Paleolithic and Holocene humans, archaic humans were likely healthier and better fed. The largest increases in human brain size throughout the course of human evolution were observed in the Middle Pleistocene. It's interesting to think about how diet and population density contributed to the conditions that led to this increase. Many dramatic changes in morphology within the genus Homo have occurred over the past 2 million years or more, including large increases in absolute brain size and decreases in post-canine dental size and skeletal robusticity. Body mass, as the size variable against which other morphological features are usually judged, has been important for assessing these changes. Yet past body mass estimates for Pleistocene Homo have varied greatly, sometimes by as much as 50% for the same individuals. During the late Middle Pleistocene, between 400,000 and 1500,000 years ago, the populations occupying Earth, and Africa specifically, looked very differently from what they do now. There is evidence for at least 3 forms of human relatives inhabiting Africa, including Homo heidelbergensis, Homo naledi and Homo sapiens, modern humans. Some, or all of these hominids made tools such as those associated with the Middle Stone Age culture that began around 300,000 years ago. Traditionally, it is thought that the larger-brained species like Homo heidelbergensis and Homo sapiens should be associated with more complicated toolkits. But the answers may not be so simple. With 3 forms of early human relatives around, things are much more complicated, according to Professor Lee Berger. So to answer the question, well, these humans probably were larger bodies, but probably not 7 feet tall on average, more like about 6 feet tall. According to the Smithsonian's Human Origins website, males averaged just 5 feet 9 inches, and females 5 feet 2 inches. The Australian Museum website says that they averaged 180 centimeters in height, about 5 foot 10.
Evidence hints that some of these different types of humans clashed. Some might have even eaten the competition. What determined who survived? Strength may have been key, brains even more so. But neither was decisive. It could have been something else.